Hello students, and you're highly welcome to this physics class that entails treating of a typical question or a topic that do come out frequently in JAMB physics. I'll be walking us through the topic radioactive decay. I'm by name Mr. Aluko Temitope. What do we know by radioactive decay? Radioactivity itself is the spontaneous disintegration, that is breaking down, of the nucleus of a radioactive element. Examples of radioactive elements are radium, rhodium, thorium, polonium. All these elements are radioactive. So the spontaneously, that is, they can just at any time disintegrate their nucleus device and then producing radioactive particles. What are these radioactive particles? We have them to be alpha, beta, or gamma ray. So those are the three radioactive particles which I expect that you will have been familiarized with them. However, when talking about radioactive decay, we have them in two types. The first one is a natural radioactive decay, while the second one is artificial radioactive decay. Why do we have natural radioactive decay? In the process of a natural radioactive decay, alpha particle or beta particle or gamma ray, either of the three, are being emitted alongside energy and other elements being emitted during the process of natural radioactive decay. But when it comes to artificial radioactive decay, a non-radioactive element such as beryllium used here, or nitrogen or boron, any non-radioactive element can be made to be radioactive by bombarding it with a radioactive particle. So that's talking about, either in this case now, we bombard beryllium, which is non-radioactive, with a radioactive particle which is helium, that is alpha particle, or a neutron. Neutron is represented by N10, that is the mass number 1, the atomic number 0. Now, talking about these decays, the natural radioactive decay is divided into three. So we can have alpha decay, we can have beta decay, and we can also have gamma decay, that is aside from the artificial radioactivity. So the particle formed during the decay process is the name given to the type of decay. That is, when you talk about alpha decay, this signifies a radioactive element with mass number A, atomic number Z. So if this radioactive element should decay, an alpha particle is produced. Helium-42 represents alpha particle. Alpha particle is represented by helium-42, while beta particle is represented by electron 0 minus 1. Then we have neutron. And then gamma ray is 0, 0. Doesn't have any mass number, no atomic number. It's neutral. So when this radioactive element decays, it produces an alpha particle. This helium-42 is an alpha particle. When it has produced an alpha particle, look at it having mass number 4. So we are going to take away 4 from the original mass number in order to have a balanced radioactive equation. So A minus 4 will give us the mass number that will belong to the new element formed. For the atomic number, Z minus 2 will give us the new atomic number of the new element formed. Then energy is produced. As we know, a radioactive reaction produces big amount of energy. So energy will always be produced. Let's come to beta particle, beta decay. In beta decay, a radioactive element having Az, that is mass number A, Z as the atomic number, also disintegrates to produce a beta particle. Helium and electron 0 minus 1 represents a beta particle, while alpha particle is represented by helium 42. So after this, how do you balance this equation with the low element form? Since the mass number is insignificant, that's 0, then that means A is still valid. You still have A up. Then the Z, since we're having -1, we are going to look at a way of balancing. If you add 1 to this, because this is deficient of 1, so adding 1 to this will make it to a balance in time of atomic number. Then energy is also produced. Same goes for the gamma decay. In gamma decay, the gamma ray itself doesn't have any impulse, that is 0, 0. Hence, the new element form still remain as Az, then energy is being produced. Coming to the last one, talking about artificial radioactivity. We said that a non-radioactive element such as beryllium is made to be radioactive by bombarding it with a radioactive particle such as alpha particle here, bombarding a beryllium that is not radioactive. They will make it to be radioactive because it's now being able to produce a neutron. It produces a neutron and it produces a carbon. So you can see that in this case, this equation is balanced in the sense that 9 plus 4 is 13, 12 plus 1 is another 13. Then you're having 4 plus 2 at an atomic side, atomic number side, then 6 plus 0 is also 6. Energy is also produced. Hence, talking about radioactive decay, we have it to be 2, natural and artificial. And when during the process, we either have beta decay, alpha decay, or gamma decay, which we have explained. And then we have artificial radioactivity as well. So the next video, we are going to consider questions under this decay. And now we are going to balance a radioactive equation. Thank you.